problem-solving mixtures. Okay, so our objective for this video lecture, we want to solve mixture problems. Well, what are mixture problems? Well, mixture problems are those situations in which you are creating a mixture from two or more things. And you're determining some quantity. It might be the percentage, it might be the price, it might be the amount, etc., of the resulting mixture. Okay? The most important piece to this, I think, is that I just simply draw circles. So I organize myself with circles. I don't get fancy and try to draw anything. I don't try to draw cylinders or anything fancy. I just draw circles. And I recognize that whatever the first thing is, plus whatever the second thing is, and maybe there's a third thing, but I'm going to add those things up, and the result of that is going to be this mixture, that I'm going to put these things together to get a mixture of some sort. Inside of these circles, I indicate the amount and the percent or the price or whatever else applies to that amount for all three of those. And that helps me come up with the equation that I can then solve. Okay, quick review of what we've been looking at for our problem-solving process. Here it is. Again, we're going to read the problem carefully in step one. We really want to be focusing on exactly what we're being asked to find, what we're looking for. Step two is draw a picture. That's not going to be applicable. I'm going to do that. I'm going to draw the circles as part of step four in organizing myself. So a picture is not going to be very applicable here in mixture problems. Step three, again, we want to assign the unknown with a letter. And we want to try to keep the number of letters or the number of variables to a minimum. So we only have to work with one equation perhaps, or maybe two if necessary. Step four, the most difficult, putting it all together to come up with an equation that we're able to solve. And once we've done that, step five, solve the equation. And then step six, let's take a check and to make sure that what we have agrees with what the problem was looking for. All right, let's take a look at a couple of examples on mixtures. First example. Okay, so we have a refinery that has 7,250 liters of a gasoline methanol blend that is 6% methanol. How much pure methanol must be added so that the resulting blend, so we're going to get another blend, we got to kind of keep that straight, is 10% methanol. Okay, so let's see here. Step one. Okay, number of liters. Notice we're talking about liters here, so we want to make sure we're clear with our units. Of 100% pure methanol means it's 100%. Notice that the current situation has us with 6% methanol. So when they say pure methanol, we want to recognize that's 100% methanol. Methanol, step one. Number of liters of 100% methanol to be added. That's what we're looking for. Okay, so we got to focus on what we're looking for here. There are no equations to worry about here, and I'm not even sure how to come up with. An initial educated guess on what it's going to be. So I'll just stop right here. Again, I'm going to make my drawing as part of my step four in this case. There's no real, drawing a refinery or something's not really going to help me. It's not like, drawing a room, for example, to get area or something. Okay, so step three, I'm again going to write it over here, just from a space standpoint. I'll let this be X. The number of liters of 100% methanol that we're going to add, we're going to call that X. Okay? Looking for one thing, so we're going to have one unknown. Okay, so here's my step four. I draw these circles. Okay, and then I label them. Again, don't get too excited about how big they are or what they look like, or my circles aren't the best, my freehand's not very good. Okay, and I'm going to take a look back over here, and I want to take a peek. Okay, in each, I talk about the thing 1, I'm adding something, thing 2 is being added to thing 1 to get the mixture, and within each circle, the amount and the percent or the price or however it is defined. Okay, let's take a look here. So this is going to be, this is the gas methanol blend. So the refinery, let me get my paper down here. So the refinery has, okay, the amount. It has 7,250 liters of a gas methanol blend. So this is the gas methanol blend. Okay, and this is the amount, and this blend is 6% methanol. So this is 6%, methanol. Okay. How much pure methanol? So this is the pure methanol, methanol. And we said that the amount here, the number of liters, we don't know. So this is X liters. But we do know it's a 100% methanol, so it's 100% methanol. How much of this do we add to this? We want to get to be added to get a blend that is 10% methanol. So we know we want 10% methanol. I can't spell methanol today. And this, of course, is our resulting blend. Well, how much are we going to have? Well, if we start out with 7,250 liters and we add X liters to it, we have 7,250 plus X liters. Okay? So it just takes kind of some, we want to use one letter, and then it just kind of takes some filling in. And as you see, my amounts in this particular problem I've written across the top of each. My initial blend was 7,250 liters. My pure methanol, I don't know that, so that's X liters. But I know my resulting blend is going to be the sum of these two things. So I just did the sum of those two things. I know that my original blend is 6% methanol. What I'm adding to it is pure methanol, which is 100% methanol, and I want my resulting blend to be 10% methanol, and there you have it. Okay, so let's make our equation in step 4. We have a 6% solution of 6% of 7,250. Okay, plus 100% as a decimal is 1.0. Okay, so we have to know that 100% is 1, 6% is 0.06, 100% is 1. 1% times the amount of pure methanol is going to equal 10%. We want it to be equal to 10% of the sum, 7,250 plus X. So there you have it. There's your equation. Okay, and I think I very much, I strongly encourage you to kind of just draw these circles and, label across the top the amounts and label across the bottom of the circles, in this case, the percent, and realize that, this one is, 6% of 7,250, the amount of methanol is going to be 0.06 times 7,250, 100% times an unknown, and then you're going to add these up and come up with this product here. So here's our math, and I need a calculator. 6% of 7,250. So this is, whoops, I forgot. We're doing step 5. Let me note that. We're doing step 5. So this is going to be 435. Well, 1 times X is X. 0.10 times 7,250. I can do that mentally. That's 725 plus 0.1 times X. notice that 1 times x and 1/10 times x are different. 1 times x is just x. We don't need the 1. 1/10 times x is 1/10 of an x. We need the 0.1 because that's different. Okay, I'm going to bring my my variable terms over to the left side. And I'm going to take my numbers over to the right side. So this is a full x minus 1/10 of an x. So this is 9/10 of an x. And 725 minus 435. I come up with 290. Okay, so now we divide by 9/10 to get x by itself. And it looks like, let's see, 290 divided by 9/10. 322. We got a 2 repeating. 322.2 repeating, and that's liters. Okay, so we just came up. Whoops, let me go back. It looks like I lost the bottom there. So here's my divide by 9/10, and here's my answer, 322.2 liters. Okay, so it looks like we need 322.2 liters of the 100% to add to it. So let's see if that works. Okay, we know, so let's do our step 6 here. And let's just see what's going on here. We know we want a result that is 10% methanol. So we want to have, let's see here, this is going to be, we want a 10% solution. Let me check my math here. So we know that, okay, so we want, let me step back for a second here. I'm getting myself a little bit confused. Let's start from the beginning. We're starting off with 6% of 7250. So 6% of 7250. If we add that 1% of 32.2 repeating, do we get 10% of 7250 plus 32.2 repeating? That's our question. We're going to substitute this into our equation. Does that make sense? And we can put that into a calculator, and I'm going to assume it does, but I'll do a quick check here. 0.06 times 7250 plus 1 times 322.222 repeating. This side is 757.2 repeating. Does this equal this side? So we got 10.10 times the sum, 7250 plus 2.222. Sure enough, 757.2 repeating. Yep, we got it. Okay, don't even need that. It is equal. So there's an example of a mixture problem. And how to solve those. Let's take a look at one more example that uses price instead, if I can find my next example. I apologize, it's a lot of writing to kind of give the problem some I guess to make the problem clear. Okay, so what do we have here? The manager of Starbucks is experimenting with a new blend of coffee. So we're talking about a mixture problem. We're going to blend stuff. Okay, she's going to mix some B-grade Colombian coffee that sells for $5 a pound with some A-grade Jamaican coffee, I hope I spelled Jamaican correctly, that sells for $10 a pound. And she wants 100 pounds of the new blend. The selling price of the new blend is to be $7 per pound. And she doesn't want any difference in the revenue from selling the new blend versus selling the other types separately. So how many pounds of the B-grade Colombian coffee and the A-grade Jamaican coffee are required? Okay, so let's see here. Step 1, what are we looking for? Number of pounds of B grade coffee required. And we're also looking for number of pounds of the A grade Jamaican coffee. Maybe it had two I's, I'm not sure. Required. Okay, that's what we're looking for. Okay, it's a mixture problem, so there are no formulas. We're looking to get 100 pounds of the new blend. So obviously each of these, well, they should add up to 100, but they should each be less than 100 pounds or fewer than 100 pounds, because the result is to be 100 pounds after we mix them together. So if these answers come out to be above 100 pounds, then we have a problem. Okay, again, no picture for step 2. So step 3, I'm going to put step 3 over here again to save myself some, so I can get this all on one page. So I'll write step 3 over here. And let's think about something here. We want to try to use as few variables as possible, as we know. So let's talk about the fact, let's say the number of pounds of B grade, that's going to be X. Now, can I use this unknown to determine the number of pounds of A grade? How could I do that? If X pounds of B grade are required, how many pounds of A grade will be required if I want to use the variable X? Well, I'm looking for 100 pounds. So if I take 100 pounds and I subtract the number of pounds of the B grade, I should come up with the number of the pounds of the A grade, because the two of these should add up to 100. Okay, so that takes care of having just one unknown, which is kind of nice. Okay, so step 4, that's our step 1. Step 2, no picture. Step 3, there. Define your variable. Step 4. Again, I'm a fan. Let's just draw these circles and let's not get ourselves too worried about how they look. Okay, so this is our B grade. We're going to add it to our A grade. And we're going to come up with our, I guess they call it a blend. Let's say they call it a blend here. We're going to come up with our blend, okay? So again, I do top line amount, bottom line price percent. In this case, it's price. So B grade, number of pounds of B grade, that's X. X pounds. And what's the price of the B grade? The B grade sells up here for $5 per pound. So $5 per pound. A grade, how many pounds of A grade do I have? I have 100 minus X pounds. And what's the price for the A grade? The A grade is at $10 per pound. My mixture, well, I'm looking for, if you want to add these two, you can, but you're going to get the same thing as it says here. I'm looking for 100 pounds. So my mixture is going to be 100 pounds. And I know she wants to sell her mixture at $7 per pound. Okay, $7 per pound. There you have it. So that really makes a big difference, having these circles and being clear of what you're putting together here makes a big difference to set up the equation. Okay, revenue. Well, if this is $5 per pound and I have X pound, the revenue for this one is 5 times X. So let's see here. This would be revenue. Revenue from this one, okay? Plus the revenue from this one. Well, this is $10 a pound, and this is the amount. So this is $10 times 100 minus X. And she wants the revenues to be the same. She doesn't want to lose track of doesn't want to change the amount of money she brings in. Revenue for this one is going to be $7 times 100 pounds. And there's your equation. So step 4 again, whoops, and I forgot to put a 4 after my step 4. Step 4 is, again, the most difficult step. I really think that just a simple diagram here helps, indicating the amount, and in this case, the price per pound and the amount, and setting it up so you can see how the equation will look. You're kind of coming right from your diagram. So step 5, I think I'm still on the paper. Let's solve this thing. Okay, so we have 5 times x plus, well, 10 times 100 is 1,000. 10 times negative x is minus 10x. And that's all going to equal 7 times 100, 700. Let's clean it up. Left side is going to be 5. Left side is going to be negative 5x plus 1,000 equals 700. So let's simplify. Let's separate. I'll subtract 1,000 from both sides. Negative, that's a 0 of course. Negative 5x equals negative 300. Okay, now let's solve. Divide both sides by negative 5. And I come up with x is equal to 60 pounds of the B grade. Remember, that's what x stood for. X was equal to, if I come right up here, you can see it. X is the number of pounds of the B grade. So the number of pounds of B grade is this. And how many pounds of the A grade? We got to answer the question. So 100 minus x is equal to 100 minus 40. Excuse me, I did the answer. 100 minus 60, which equals 40 pounds of, whoops, my paper's getting low here, of the A grade. Okay, there you have that one. I've run out of space on my paper, so I'm going to leave the check to you. Obviously, you want to come up with right here that 5 times the 60, okay, is the revenue from the B grade, plus 10 times 40, which is the revenue from the A grade, should equal 700 right there. So there you have it. Again, I strongly encourage you when you're working with these mixture problems, it really does make a difference if you just kind of go with circles and then fill in across the top the amounts, and then across the bottom either the percent or the price, or however they're working with those amounts.